We are going to find the magnitude of a vector, and we are given the initial point and the terminal point. Notice that the origin is not included in this, so this is a vector floating out in two-dimensional space, and we need to find this magnitude. So the first thing that I want to do is I want to do a quick sketch of this so that I have an idea what I'm looking at and that you have an idea what I'm working with. So this is my sketch. I have this vector floating out in space here, and it starts here and goes this direction because this was the terminal point. So I have a magnitude and I have a direction, so this is definitely a vector. The first way that I want to find this magnitude is I'm going to use the distance formula, or the magnitude formula, however you have learned it. In geometry class, you probably learned this as a distance formula, and then looking at vectors, you're learning this as the magnitude formula. It's the exact same thing. It is a modification of the Pythagorean theorem. After we do that, I want to go back through and look at this calculation again, finding the magnitude using a dot product. So I have a dot product rule listed here, which says that the vector dot product by itself will give us the magnitude squared. So once we find whatever this value is, we'll take the square root of it, and hopefully it matches this original way that we calculate it. So the first thing that I want to do is I want to label my givens so that it fits this formula. That's not a bad idea, and it's a nice habit for you to get in. It helps you keep track of things and helps you when you go back to substitute. So I'm just following this formula, and so I need x sub 2, so I pull that out of here, and I'm going to subtract it from x sub 1. That's all squared and added to y sub 2 minus y sub 1. And that's all squared, and we take the square root of that. When you do this squaring and addition process, you're looking at the square root of 20. This is not going to be a rational number. It's going to be 2 square root of 5, which is approximately equal to 4.472135.9. I'm running out of space. This keeps going because it's irrational. So this is an approximate answer. This is an exact answer. So this is our magnitude. That's the length of this vector here. So now I want to look at doing the dot product, and for that I need the component form of this vector. So let's look at figuring out the component form of this vector. We need something that's 90 degrees here. We already assumed we were working with a 90-degree triangle if we're using something that involves the Pythagorean theorem. What is the base of this triangle? If I start at this point and I count over to where this vector's point is straight down, we have 1, 2 units, and then I want the height, so from the base to the top of this vector, we're going 1, 2, 3, 4. So the component form of this vector is 2, 4, and I'm going to use that to do the dot product. So this says I'm taking the vector dot product itself. So I'm looking at 2, 4 dot 2, 4. So when I do that, I'm looking at multiplying the first terms and then adding it to the product of the second terms. So 2 times 2 plus 4 times 4 is going to give me 4 plus 16, and that's 20. So this is the square of the magnitude according to this rule. So I need to take the square root of this to know what the magnitude is, and this is exactly what we had up here. So we know when we work through, if we put this in another form, we start taking the square root, we get 2 radical 5. If we work this out on our calculator, we get this approximate answer of 4.47. So it's the exact same answer. So it doesn't matter the method that you use, you're going to get the same answer. So unless you are told specifically to use a certain method, either of these methods are a good option for you, whichever you like best. Of course, if you're told to use a specific method, you should use that method. because if you're in a testing situation, they're testing that specific skill, and that's the skill you need to demonstrate. Cheerful Calculations.